So good morning, friends. As part of the last few classes, we 1 minute. Any update on the lab which you mentioned to create? Yeah, we are still in progress. Means we are trying to simulate what CloudX Lab is providing, so that I can start providing the lab. Are you talking about that, or are you talking about something else? Yeah, it will take some time. Means setting up the infrastructure is not a big deal, but developing the website we are working on. We are almost 70-80% done. Uh, uh, we will we will start in couple of weeks. Okay, so I will give you free access for all of you for a month or so that you guys can test and provide the feedback about the lab, and then I will announce to public at nominal price, the way CloudX Lab is doing. Okay, so here so far as part of Spark, we have seen PySpark, and we have discussed about core Spark APIs such as transformations and actions. Okay, so in the similar line, instead of Python, we will be using the Scala. I will not be covering all the concepts again. I will take two examples, calculating the average. The same program we will try to execute in Scala, and we will see the difference between Python and Scala. And also I will try to show how to write a query that produces ranked or sorted data using Spark on by key. Okay, so these two are the topics which will be covered instead of going through again, because concepts are same. You have to focus on syntax and semantics of Scala for now. And also I will try to showcase data frames little bit, wherein it's out of scope for certification, but data frames is the concept where you can have a structure on the data, and then you can start querying the data using data frames. So I will show that also as part of this class and next class. So first thing is calculating aggregate statistics using Spark. I will directly go to, is it by key? Yeah, it is by key. So we'll be talking about by key. So if you see here syntax, 1 minute, let me zoom in a little bit. If you see the syntax here, um, it's almost same. This part is same as Python. Only thing is you have val here. So Scala is also loosely typed. You don't define types most of the cases. Unlike Python, you have to define types at some in some cases, but most of the cases you don't need to define uh, types in Scala. But you have to tell whether it is a mutable or immutable object. So what is mutable or immutable object? For that, let me log into the lab and give a simple demo to explain you what is mutable and what is immutable. Then you will understand why we are specifying val here. Okay, I'm launching Spark shell. So it is started here, and this is a Scala based interface. So regular Scala programs also you will be able to execute here. Okay, so now I am showing what is the difference between val and var. Let's say I define val I equal to 0. Okay, val means it's immutable. You cannot change the value I anywhere. Okay, val I equal to 0. Now if I say I, so here you can see it is giving the data type and the value. Okay, so if I want to, so if you are developing the program, you will declare variable at one place and you will be changing it over time in typical programming languages. So if you want to change, you have to define it as val. If you just define it as val like this, and if I want to change the value of the variable I, okay, like this, it will fail because we are trying to assign it to a val. Because it is immutable, I cannot be modified as part of the life cycle of the program. So you should, even though we are working on interactive fashion, you should think from the program perspective. In the program, you will declare variable in typical programming language. You will declare variable in one location, and you will try to reassign the variable many times later. Okay, but when you try to reassign a new value to the variable, there is a little bit of overhead in the programming language. So the programming language have to replace the value in the memory uh, uh, with the new value. So mutable values, mutable variables take some overhead to manage. Okay, so overall, if all your variables are mutable, then that overhead can be significant in some of the when you try to develop low latency applications with so many variables in them, and if all of them are mutable, then it can add little bit of overhead, and it can be significant in some of the cases. So for that reason, you have so even though you don't need to specify data type of the variable in Scala, in most of the cases, you have to tell whether it is mutable or immutable, and that way a little bit of overhead will be reduced. Same thing, if you want to, you can do this. Even though you cannot assign like this, you can again say, give the variable name with I and give value to that. Now it will change. The reason is, when you say val, it is destroying the old object. Means when you are declaring it as val again, it is destroying the old object and recreating the new one. So it's not actually trying to change the value of the variable I here. It is actually recreating the variable. It is like giving the same name to two different persons. After so I, after killing it, we are giving the same name to some other variable, the same name to some other variable. So that is about val. It's immutable. Okay, so mostly we will be using immutable variables because we will not be updating the same RDDs as part of our applications. So when it comes to Spark with Scala, most of the times you will see val, not var. And if you want to use mutable variables, for example, it is typical that you increment and assign the same value to increment and assign the incremented value to the same variable. It is quite common in the for loops. So in that case, if you want to use if you want to write for loop where a variable is created and value is incremented and assigned to the same variable, those type of scenarios requires mutable variables, and the way you declare mutable variable is with var. Var means mutable, val means immutable. Okay, and if I say I equal to 1 here, it will work because this I is already killed and a new I is created with the same name. And now if I say I equal to 2, it will change because it's mutable. Sorry, immutable. So this is one of the important concept of Scala. What is mutable and immutable? If you claim that you have some Scala experience, this is one of the fundamental question you might encounter at the time of interview. Okay, so make sure you are clear about the difference between val and var. So if someone claims the experience, the first question I will ask is this one. If they could not respond, then there is no point in discussing anything related to Scala with him. I typically do not waste my time or the person's time if they are not good in these kind of fundamentals. Okay, so and most of the quality interviewers are like that. They ask very basic questions to begin with, and if they could not answer, they will move on to the other topic, and within few minutes they will decide whether the candidate is good or not. Okay, so this is one of the most important aspect, and we will be using immutable variables most of the time. But while processing, if you want to loop through, then probably we will use mutable variables. But in actual Scala applications, you will see mutable variables also quite frequently. So now to read the data, we are actually this is the only difference to read the data. You have to define whether it is a val or var. Okay, rest of the stuff is same. The syntax and the API is text file, and also when it is launched, it will have a immutable variable called sc, which is assigned to Spark context, which is assigned with Spark means which is this is nothing but Spark context object, which is being created when the command line interface is launched. So if you see here, when we run Spark shell command, it has done so much of stuff before giving us this interactive interface. So in those steps, somewhere it is also creating this Spark context object with name sc. If you want, you can change the name and you can use that name instead of sc. But as sc is already there, we will be using that only for both PySpark and Spark shell, and the behavior is same. Okay, so the rest of the stuff is same. So I am actually running this command directly instead of typing to save the time. Okay, here unlike PySpark, we used to, if you see here, if you want to develop in PySpark to write the code in multiple lines, you have to use this Linux based backslash to break a single line into multiple lines for readability purposes. But with Scala, you don't need to do that. So if the command is not complete, and if it is if you use equal to or dot, so the punctuation marks, and go and hit enter, it will go to the next line, and it will expect you to continue the command. Okay, so that's why we don't see that backslash as you see in PySpark. That is another difference which you need to keep in mind, because you have to hover between Python and Scala while developing the code snippets for the certification. So in certification, at the certification time, this can be a little bit confusing. If you want to write the code in multiple lines, remember that Python expects you have to line break wherever you want to break into a different line, whereas in Scala you don't need to do that. You just start using a new line after a punctuation mark, and it will work. Okay, and then in this case, we are trying to get again the problem statement. So first I will run this. I will just try to get the orders by status using orders by status using count by key. Okay, so to apply the count by key, I have to extract the key from the data. And what is the key here? If you read the data, orders rdd dot for each println. So this is how you can iterate through collection. RDD is nothing but a collection, a special type of collection in Spark. Okay, so to iterate through collection, you can say dot for each of println, and no, I have to use action here. So after the RDD name, I have to say either collect, so that it will start collecting from the collection, or take if you want to get the sample, and then out of that I want to display by using for each. So this is how it will look like. I think somewhere, okay, input path does not exist. So it's again Scala and Python both are lazy evaluation programming languages. It's not the Spark, it's actually the programming languages. So the programming languages uses the concept called lazy evaluation. So again, the lazy evaluation is another important fundamental concept which you need to understand. So what is lazy evaluation? If you see here, initially I ran this command to read the data. Even though the path is not correct, It did not actually did the validation whether the path is correct or not. It will do the syntax checks, but it will not do the semantics checks. It will not go ahead and see whether the path is valid or not. Only when you see certain APIs, such as actions in this case, um, Scala or Python will start executing the program. It will actually do the semantic check, do the final compilation, and then it will start executing the program. So that's why it is called as lazy evaluation, because the evaluation is deferred till the time when you start executing the program. Okay, and again, some of the Python is not compiler based programming language. It's interpreter based programming language. So it will not even compile. It will directly start executing once you issue certain type of action. Whereas Scala, it will perform the compilation and then it will execute. Scala is not interpreter based programming language like Python, PHP, etc. It is like Java. It's more like Java, but still it follows the lazy evaluation, which is more prominent in programming languages such as Python, PHP, etc. Okay, so here I will come back to that. So Spark is not a programming language, Pramod. It's just a kind of a distributed computing framework. It's not a programming language. We are using, and they provide APIs for Scala, they provide APIs for Python. Okay, even though you are saying Spark shell, you are getting into the Scala interface only. When you say PySpark, you are getting into the Python interface. So there is a difference here, and lazy evaluation is a concept of programming language than a tool. Okay, as per my understanding, Spark, it's not the feature of lazy evaluation is the feature of programming language more than an underlying tool. You can correct me if I am wrong, but that's my understanding. Okay, so now I have changed the path, and I will try to execute this program. Now you can see the data. So this is how you have to read the data. Okay, up to here it is same, but to iterate through this, in Python we have used for in and gave this and then semicolon and then print, whereas in Scala you can just iterate like this. Again, this is take and for each are Scala concepts. Okay, and orders RDD is just a special type of collection, which is the feature of Spark. Okay, it's part of Spark API. RDD is part of Spark, whereas the rest of the stuff is from Scala only. So you can also say val I equal to 1, 2, 3, 4. I think I have to give the type here. Okay, I think I have to give I list of int. Okay, so I'm creating list of int and then 1, 2, 3, 4. I forgot the syntax. I got it. Actually, I have to use list of. Here I have to say list of. So if you look into this and Python, you don't need to specify data types anywhere. But in Scala based Spark, you have to, or as part of Scala, you have to specify data types quite frequently. But for simple things, you don't need to do that. So here, if I have to create a list, I have to define what type of list it is, like this, and then I have to invoke the constructor of list like this, and then I can assign the elements. Now if I use I dot for each println, I will get the data from the list. So this is what we are trying to do. RDD is nothing but a special type of collection from Spark using which overrides some Scala collections, and then you can apply all those operations that you can perform on a typical Scala collection on top of RDD itself. So that's what we have done. We have taken 10 records out of the RDD, and then we are iterating using for each, and we are printing the data. Okay, so now we have to apply the transformation. Let me see the question. What is colon represents here? Okay, so it's just the syntax. To define the data type, you have to say colon after the variable name, and then you have to tell the data type. For example, if you want to just explicitly set the data type, you have to use this one, val I colon and the data type of it, and you can say 0, and also it is same as this one. Sometimes it will infer, sometimes we have to tell. Oh, we cannot say this. Int type does not take parameters, so int will not take parameters. So we have to directly assign like this. Okay, so a colon is primarily it's as part of syntax while defining the data type. So this is the complete syntax to define the variable, whether it is mutable or immutable, and then you have to give the data type of the variable. Okay, so now we will see how we can apply the map function and extract the key, because we want to get the count by the status, and this is the status. So this will be the key, because we have to get count by that. So to extract the key, yeah, we have to use toInt, correct. To extract the key, we have to apply the map function. The way we have done with PySpark is the same thing. And the way you apply map function, if you want to create again another immutable variable, you can say val and orders map RDD equal to, and here in Scala it will autofill. Okay, so there is only one variable so far, even with one character, which there is only one variable so far which starts with O. So if you hit tab, okay, it is actually showing other things which are already available as part of Spark this interface. These are all predefined variables. Okay, predefined some variables or whatever it is, keywords or whatever it is. So it is trying to report what are all available which starts with OR, and then you can hit a tab and it will autofill. And even after dot also, you can hit tab to autofill. For example, I can say MA and tab, and it will show what all functions are available which starts with MA. This feature is not available with PySpark. There could be a way where you can enable that, but default it is not there. Okay, so I want to use map function here. So if you remember, we have been developing lambda functions. So in Python they call it as lambda function, and also some people call it as anonymous functions. Okay, so in Scala it is more popular as anonymous function, but both are same. The concept of anonymous function and lambda function are same. You will be creating the functions without the names, and whatever parameters will be passed, you can actually invoke those as part of the code. Okay, so here as part of the code for that lambda function. So here the way you define lambda functions are, you just have to define the variable. So in this case I want to name it as rec, because I'm trying to process one record at a time depending upon the file format we use to read the data, which is text file. So each line will be one record. Rec equal to imply. So imply is the syntax to define that it is a lambda function. And here I want to create a tuple. Okay, so the second bracket is to close the map function. So as part of the tuple, I want to split the record, and the way we have done, rec dot split with the delimiter which is comma. Okay, and then when we split, it will generate array. Okay, and in Python we have used square brackets to read to pass the subscript to read element from the array. In this case we have to use circular brackets. Okay, and we are trying to read fourth element, so we have to use 3 here, and then the second element of the tuple will be we are trying to get the count, so we can just pass anything because we will be using count by key. You as a placeholder you can specify anything here, and I am specifying it as 1. Okay, and hit enter. Now if you want to preview the data, you can say orders map rdd dot take of 10 dot for each println and hit enter. You can see the data. You got the key which is order status for each from each and every record, and the value which is 1. Okay, now you can use count by key on this. So orders map rdd dot count by key. Count by key is action, so you don't need to again get one more action to execute. When you run count by key, it will automatically run the program, and you can see it has created a map. Okay, so if you want to read it in appropriate fashion in separate records, you just have to use for each println, otherwise it will just report like a collection. So you can say for each println, but before passing it to for each println, we don't need to use collector take here, because count by key is an action, not the transformation. Okay, and hit enter. Now you can see the data. We got the data with we got the count for each of the order status as part of our orders data. Okay, so this is how you can start developing the program. So we have covered so many things so far within this example. We have covered how the variables should be declared, what is the difference between mutable and immutable. We have covered what is the concept of lazy evaluation, and also we have covered how to invoke the functions such as text file to read the data from location in HDFS. By default, it is in HDFS because it is integrated with Hadoop and Yarn here. If it is not integrated, then what you have to do is you have to give the path. You have to go to coursesite.xml, get the fs default fs value here, and you have to paste that part here. Similarly, if you want to read something from locally, you just say file. You have to give 3 slashes to begin with, and then you have to give the fully qualified path to read the data from the local file system. If you don't specify that, in this case it will directly go to HDFS. Sometimes as part of the configuration they might configure to read local from local directly. In that case you have to specify the HDFS and give the entry from coursesite.xml. So Venkat is asking, can you explain again on imply? So there is nothing to explain here. So it's again, it's the syntax. Okay, you have to follow that. You have to memorize and you have to follow. So we have to use anonymous functions or lambda functions. Okay, the way we have used in PySpark, we have specified lambda rec colon. So that's how you start with the lambda functions. In Scala, you just have to give the variable names and imply. So this will make the Scala compiler understand that we are trying to use lambda function. It's a syntax you have to remember, that's it. Okay, if it is Python, you have to use lambda rec semicolon. Lambda rec colon. And if it is Scala, you have to just say the variable names. So rec is just a variable name. Don't think that we have to give rec only. If you want to pass it paired RDD, if you want to apply something on paired RDD, you might have to define it as a pair or tuple. So it's just a variable name here. Okay, and the data type also can be different. We will see those examples later. But main thing is whatever you want to define, whatever variables you want to pass as part of your lambda function, you have to give those variable names here, then imply. Once it sees imply, everything after the bracket will be considered as by looking that part, it will think it's a lambda function and it will start interpreting or compiling the program using the similar manner. So do we, Mohan have asked a very good question. He asked, do we use OOPS concepts while coding in Spark using Scala, or basic Scala is good for developing programs? To begin with, basic Scala is good, but slowly you have to get into OOPS concepts. Okay, if you want to develop programs using Scala, otherwise you you will end up with so much of redundant code. Okay, they made it OOPS for a reason. So if you want to leverage that, you should use OOPS concepts also while developing the applications. But again, for certification, especially for CCA, it's not about OOPS concepts. Even HDP CD Spark, which is newly announced, is not about OOPS concepts. You have to develop Scala-based or Python-based Spark programs, Spark applications, but they don't emphasize on OOPS concepts there. So for certifications, you can ignore them, but yeah, eventually you have to have the skills of Scala. And Scala is beyond Spark. Don't think that Scala and Spark. Don't think Scala and Spark together. Spark is a tool or distributed computing framework which supports Scala and Python as a programming language. Scala in itself is a very big technology, and uh, um, you can actually develop full-blown applications with Scala itself. So it's not just one video. I have to develop a lot of content. It will take at least 4 hours or 6 hours content to explain all the important concepts of Scala. I have it in my pipeline, but it will take time. I cannot do it at this time. It will take time, and I have to develop at least 4 to 6 hours of content. There are so many concepts like class, object, trait, many other things. So eventually we'll learn, but as of now, it's not on my top priority list. My top priority is to come up with the big data engineer content. Then I will start working on these programming languages. Okay. Anyway, I hope Lambda functions are clear to Venkat at this time. So I'm now moving on. So this is already executed, and yeah, we have learned also how to apply map function to split the data, how the data from an array should be read using circular brackets, not the square brackets. Typically, in most of the programming languages, it's the square brackets. Okay. Now I will try to show the same 1 minute. Yeah, now we will go to the next major thing directly, which is to compute the average. Okay, so I'm not going to cover what is combiner and all those things here. I will try to directly implement using joins, um, uh, reduce by key, as well as aggregate by key to compute the average. So stay focused, because we are trying to cover too much of things without refreshing the basics, assuming that you have done enough practice with Python. If you have any questions, you can let me know at any point in time, but I'm assuming that you are already proficient in this and you have practiced using Python. If not, if you have any questions, we will see those questions at that time. Okay, so here let me copy these 2 lines. I have to open Sublime Text. I'm opening another file. I have to make certain changes. What happened? Okay. Okay, so I'm reading the data for both orders and order items. Okay, and then we have to join this data. To join this data, we have to use map function and extract the order ID for both. If you remember, Order ID is primary key in orders table. Order items, it's the second field in the table, and it is the foreign key to the order ID in orders. And the actual column name in the MySQL database is order item order ID. So we have to join based on order ID. So we have to extract order ID as key for both the datasets, and that's what this logic will do. And I'm not going to cover the map function because I already covered. I think it is clear for you. If you have questions, you can let me know on these 2 lines of code. Okay, and now we are trying to join. So as I have mentioned to you earlier, join happens from one collection onto the another collection based on order ID. And if you try to see the sample of passed any of these passed RDDs, you can see take of 10 for each println and hit enter. You can see, so this is one more thing which you need to keep in mind. Here we are using comma as the delimiter, okay, and if you see, everything is delimited by comma, but this is actually a tuple. If you see, this is in circular brackets and it's a tuple, okay, and the first element, there are only 2 elements in this tuple. The first element is this one, which is order ID, and the second element is this entire string, which is the record from orders table. Okay, so this can cause significant amount of confusion if you do not practice, especially if you are using comma itself as delimiter. If delimiter is something else, it's a different story. I haven't even come to the point where I have started using underscore. I will explain when I am at that point. Okay, I will cover that. Okay, so the question is little bit early, so do not worry, that will be covered. Okay, so here what I'm trying to say is, it's a tuple, and if you are using comma as delimiter, you have to remember where your first element ends. So in this case, our key, if you look into the code of map function for orders, we are extracting the first element after splitting by comma on the record, and also we are passing the record as the second element itself. So this one will only return one value most likely. Okay, so this is the first element in the tuple, which is being generated as part of output of map function, and this is second element of tuple. So it can cause significant amount of confusion if the data have the comma as delimiter. So you have to keep this in mind. Okay, so now similarly, orders items also will get order ID or order item order ID as the first element in the tuple. I will also pass order items also. So you can see here, so this one and this one is same, because we are getting from the second element after splitting by comma as the key here for order ID. So now using this first element, join will happen when I apply the join function. It's the same thing as we have seen in Spark, so I'm not getting into too many details here. You can go to transformations and actions under the documentation, and you will understand. Now we will review the data. So it's very important to review the data after each and every step and understand the structure of the data. If you understand the structure of the data, developing your program will be much more efficient and also less bug prone. You have to review the data while developing after each and every step to understand how the data is structured. So in this case, when it comes to Scala, it will actually report what type of data type it is using internally. With Python, it does not. So you can see that the variable orders join order items. So this is the variable, and this is the data type of that variable. Okay, and what is assigned is the map partitions RDD, which is implicit RDD, which you do not need to worry about, but you should focus on this aspect. So what this orders join order items is of type RDD of package org Apache Spark RDD, and in that it will have a tuple. Okay, RDD is nothing but a collection. That's why they are using square brackets here. As part of the square brackets, they are showing tuple. So RDD is nothing but a, in this case, this RDD is nothing but a collection of tuples, and that tuple have a nested tuple. So the first element is plain string, and the second element is a tuple of again string and string type. Okay, so there is a nested tuple, and a nested tuple have two elements, and both of the elements are of type string. Now let us preview the data to understand how it is represented. Order join order items dot take of 10 dot for each println. So the now join have happened, and you can see the data is printed in circular brackets, which means it's a tuple. First element is just order ID, and if with Python you see, if it is alphanumeric, you see U, which is you see it like this, U2828, which means it's Unicode string. Okay, here it does not show that, it will just print out. You have to understand the understand the data type by looking into the type of that object. When you actually where is that, when you just any point in time, once you created the variable, if you hit enter, it will give the details about the data type. Using this you can understand what is the type of each of the element. Okay, the second element is again a tuple, and if you see, it's a free flowing comma separated record, but it has two elements. So you have to be extremely careful in this. So you have to understand what is the first element in the tuple and what is the second element in the tuple, and how many commas are there in each of the record. Okay, so order items have 6 fields. So 1, 2, 3, 4, 5, 6. Okay, so till here it's an order item record. So first element of the tuple is still here, and second element of the tuple is from here. Okay, and why I'm counting manually is that you have to use later. I will explain that. So so this nested tuple have two elements, and each one is of type string, which have the data which have commas as part of that string. So that's how you should interpret. So this is where a lot of people get confused, especially while dealing with comma separated data. Typically in projects, we does not use comma as delimiter. We use a special character or pipe or colon as delimiter, because comma is most frequently used character compared to colon or others. Most of the addresses will have comma. So whenever you have your data, whenever you have address as part of your data, and if the entire data set is delimited by plain comma, it will mess up the data. So typically people don't use commas as delimiter, but in certification, if they give comma separated data, and most of the guys use comma separated data for exploration or practice purposes. So there is a high probability that they might give data with comma as the delimiter. So you should know how to make sure it you should know how to interpret the data and write the code accordingly. Okay, I hope it is clear. Let me see the question. Where can we change language settings of default? I am not sure, Mohan. Okay, so now you have so we have the tuple, and the tuple have the nested tuple. The first element is plain string, second element is a tuple of two strings. One is the record from order items, and the second one is from orders. So now I will take a example of this, and now I am going to that underscore notation what Gopi have asked. Okay, so I am creating a variable called val I. Okay, and it is of type tuple string comma string comma string. Okay, so this is what I'm trying to create, and in that I want to first 2828, and then I want to pass till here as string, and then from here to here add another string. At least they should have enclosed in the double quotes. Okay, I have to pass this also as string. 2828 is also string. Either I have to put it in double quotes or I have to use toStr function or something. Okay, now we have, so now you see this same string is resolved into whatever we are looking here. So now if you want to read these elements, how to read these elements? So Scala have a different type of syntax. Okay, so here I is complete value. Okay, and if I say I dot underscore 1 and hit enter, it gets the first element of the tuple. If I say I dot underscore 2, it will get the second element of the tuple, and second element of the tuple is again of type string and string. Okay, and if I say I dot, so now I dot underscore 2 is a tuple. If I want to get the first element of the tuple, I have to say I dot underscore 2 dot underscore 1. Here the subscript ID starts with 1, not 0. Okay, so there are two deviations from the typical programming languages. When it comes to array, Scala try to read the data using circular brackets starting from 0, but when it comes to tuples, it uses this different notation called underscore notation, and the subscript index starts with 1, not 0. Okay, in this case, if I need to read first element of the tuple, I have to use underscore 1, and this is the one which you see, and this is the second element of the tuple, and second element is nothing but a tuple of type string and string. And if I need to read the first element of that nested tuple, I have to say I dot underscore 2 dot underscore 1, and it gives us order items record. If I say underscore 2, it will give orders record. Okay, so if we have to process the data, if you have to get order date from this, what we have to do is I dot underscore 2 dot underscore 2 dot split, comma is the delimiter, and it will generate array. If I run split, you can see it is generating array, and out of the split I want to get the second field, which is this one, and here it is represented as 1, not sorry, the index will start with 0, hence we have to pass 1 to get the date. So we got the date. Okay, I hope it is clear. If you have any questions, let me know, because this is the very important aspect while developing our rest of the logic. Okay, I'll come back to that again. That also very early we will talk about that. Okay. Mohan have asked me, sometimes while processing the data we may encounter different language settings, so how to deal with it? I am not sure, I haven't explored that yet, so I will keep that in mind and I will get back to you with an answer for that. This is for Mohan's question. Okay, so is it clear about how to read the data? Okay then. So subscript is nothing but this one. This is called as subscript to read an element. I think we can. I heard somewhere that they are called as subscripts. So in an array, if you want to read an element, you will pass it the index of the element or ID of the element as part of the subscript. Okay, and here we use circular brackets in Scala. In Python we use square brackets, and for tuples in Python we use square brackets only, but in Scala we use this underscore notation. So that's the difference about how you access tuple. I didn't how system knows like the first part ends with 129.99. So here let me show you what I have, how I created I. Okay, this is how I created I. Okay, I clearly defined what is my first element and what is my second element while creating the I. Okay, so that's how it knows. Okay, so let's move on. So now using this information, I want to um, um, after joining the data set, I want to get order order date and order ID as key, and order item subtotal for each order item as value, and this is the logic here. So the way I have extracted date with using I, the same logic is applied here. T dot underscore 1 represents the order ID. So I want to have a tuple as key, which includes order date as well as order ID, so that I can compute revenue for each order, and then using that information I will use aggregate by key function to get the both total revenue per day as well as total number of orders per day. Okay, so this is the similar logic which we have used when I execute the program second time using Python. Okay, so now you can see that the RDD is of type tuple. First element of the tuple is nothing but a tuple which have two strings, and the second element of tuple is of type float, which is nothing but order item subtotal. Okay, so if you first let us read orders data. Orders RDD take off 5 dot for each println. Okay, this is orders data, and then order items RDD take off 5 dot for each println. So this is order items data. One minute, I have to update that. I have to copy this one also into the Sublime text. Okay, so now this is order items data, and this is orders data, and last RDD which we have created is this one, orders join order items map. Okay, if you look into this and say take off 5 for each println and hit enter. So you got, so let's look into the 37231, that will make more sense. Okay, so in this way we will also see how to use filters, filter transformation as part of Scala, Spark shell. Okay, so orders RDD dot filter, we have to use lambda function here. Rec is the variable name, and then rec dot split by comma, and the second I want to get the first element from the array because we are trying to filter from orders. Okay, 0, and if it is equal to 37231, then only I would like to get it, and I have to typecast it here. So toInt is the function of Scala to typecast. Okay, so I am converting the order ID to integer, because as we pass it from the string, by default it will assume that it is a string, and we have to convert it into an integer. Okay, and then hit enter. Yes, it is working. So for each I have to use collect for each println and hit enter. So there is only one record in orders table. Now we will do it in the order item sheets as well. Order items, only difference is here we have to say 1 because order ID in order items is second field, and you can see there are 5 records. Okay, so this order ID is actually generated on 2014 March 11th, and there are 5 records here, and that's what it is showing as part of this one. So 37231, because we are using take of 5, it is only showing 4 records, but there are 5 records. And for each of the record in order items, we are getting order date joined with that along with the order ID, and we are getting the order item subtotal, which is this one for each and every record. So that's the output of the map function after joining. For each record in order items, you will see a record after this map function where the output is nothing but a tuple of date and order ID and the order item subtotal for each record. Now using this we can compute the revenue. Okay, at order ID level. It's not at order date level, it's order ID level. So now we have to evaluate all the aggregate functions. We have group by key, reduce by key, and aggregate by key. Which one we should use? We should not use group by key because it does not use combiner, and in this case the number of records will go down significantly after applying the aggregate function. Hence we should not use group by key. Out of reduce by key and aggregate by key, we have to evaluate against 2 criteria. The first one is whether input type for the aggregate function and output type of the aggregate function are the same or not. So in this case, input type is float, input value type is float, and output value type is also float. It's just sum of these values which will result in a float. So the first criteria is satisfied. The second criteria is whether the combiner logic and reducer logic are same. So our logic is simple. It's summing of all the records. Okay. So in the for summation, it satisfies. The combiner logic and reducer logic is same. So as combiner logic and reducer logic is same, and also input value type and output value type for the aggregate function are same, we can directly use the reduce by key function. So that's what we'll use here. Okay, so let me copy first into Sublime Text. So now it has created the same type of RDD, which is of type tuple, and the key is nothing but a nested tuple of order date and order ID, but value is aggregated revenue. So now you will see only one record for this 37231 out of this one. So I will be filtering, I will be applying filter again, filter rec. Here I want to get this one. Okay, so this is from the tuple. Okay, so rec dot underscore 1, so which will get us this one, and then dot underscore 2, okay, which is this one, and then we have to convert into integer equal to 37231 dot collect for each println. So now you can see that there is only one record in this which is aggregated at the order ID level. So using this RDD, we can actually compute and the revenue per day as well as total number of orders per day. But before applying the next aggregate function, we have to discard the order ID from this. Okay, so that's what this do, because from here we have to discard order ID and we have to aggregate at the date level. You can keep it and still you can aggregate, but I will discard it. Okay. So here I am discarding it. So if you want to keep it and if you want to still run it, then you have to customize partitioner in Spark, which is not considered as core Spark. It is more of advanced concepts, and I will not be covering that. But if you want, you can keep it. But in this case, you don't need to. In some extreme cases, you have to do that. So once you copy paste this one, and once you preview the data, take off 10 for each println and hit enter. So you see only date, not order ID, and there will be multiple entries for the same date here, which has to be aggregated to get the revenue per day and also total number of orders. And now again we have to evaluate which aggregate function we should use. We cannot use reduce by key. The first criteria itself fails because the input type for the aggregate function is just float, which is this one, whereas the output type is tuple. We are expecting both total number of orders as well as total revenue. Okay, for that reason we cannot use reduce by key. Instead we have to use aggregate by key function. Now this is the key. Again you have to focus on here to understand aggregate by key function here. So in Python we pass three parameters. The first one is the initialization, second one is the combiner operation, third one is the combiner logic, third one is the reducer logic, or sequence op or combiner op. The terms are a little bit different. Okay, so the first one is initialization of the output value. Second one is combiner logic or sequence op from Spark terminology. Third one is reducer logic or combine op. Okay, in Python you just give as three parameters, but in Scala you have to initialize in one circular brackets. It's just syntax. I don't know the logic behind it. You have to use something like this: aggregate by key, and you have to initialize in this first circular brackets, and then in the second circular bracket you have to give the sequence op and combine op or combiner logic and reducer logic. Okay, and this is the logic for the combiner or sequence op. This is the logic for reducer, which will get us the total number of orders, total revenue plus total revenue as well as orders for each day. Okay, so this is how you initialize. The first element is float. In Python we just say 0. That is enough. As long as it understands that it is numeric, it will take care internally. But when it comes to Scala, we need to be a little bit more explicit. So for float we have to initialize like this. For integer we have to initialize like this. Okay, so and it's a tuple type, so that's why we are giving in circular brackets. Even in Python we have did that. The first element is a tuple, so we put it in circular brackets. Okay, and then the first parameter in this section is the combiner logic. As I have explained earlier as well, out of these two parameters, this one is of type tuple, which matches this one, whereas this one is of type the previous RDD on which we are trying to apply this function, the value of it. So the value of revenue per day order map will be the second element of the tuple. So that's why we are using subscript for this one, because it's a tuple, but no subscript for this one because it's plain float value. Okay, this is another thing which you need to understand for sure, otherwise it will cause a lot of confusion. So it all depends upon what is being passed to this function. Okay, so here we are trying to apply aggregate by key. So what is the key here? The key is date, and what is the value? Value is this one. So for the sequence op or combiner logic, okay, The second parameter, it's a paired RDD, so you have to pass two things. So the first one is accumulator. Accumulator is of, it has to match the output value for our aggregate function. So it is, you have to use subscript while accessing the accumulator as part of this combiner logic. Okay, and the second parameter in this lambda function or anonymous function is nothing but the value from the RDD on which this aggregate by key function is running. So on this RDD, the value is just plain revenue. Hence, we can directly add it. Sometimes we might pass a tuple also here. In that case, you have to you have to extract the tuple, the relevant tuple, to add it to the accumulator. Okay, and then for the second element, as part of the output, we want to get the number of unique orders for a given day, and this is how you can do it. So in the accumulator, for the second element, we are trying to add 1. Initially accumulators are 0, so it will generate a lot of intermediate values, and as part of the final logic, we are adding first element of the tuple to get the revenue, and second element of the tuple to get the total number of orders for the day, total number of unique orders for the day. So you can just copy this one and paste it here. Let me paste it here also. In case if there is any issue, I can fix it. That's why I'm pasting here as well. Okay, so that is how you, now if you look into this one, revenue per day dot takeoff 10 for each println, and you see we are getting revenue for each day and the number of orders. If we divide these two things, we will get the average revenue for each day. And also, sorry, I copied. And also we can actually see how many records are there in this. So we have to perform sanity checks at regular intervals to make sure it is working as expected. One of the sanity check is to run count and we see that there are 364 records because there are 364 dates in our data set. Okay, I know the value for sure, and that's why I'm confident that this program is doing what I'm expected to do. At least by performing the sanity check, I can be more confident. There might be bug in the code and there might be bug in generating the revenue or total number of orders, but at least it is doing something by aggregating at day level. That we can easily confirm by just taking the count of the elements we have as part of the final RDD. And now to compute the revenue, to compute the average revenue, you have to apply the math function again. And here I am extracting the first element to 1 minute. Why I am doing yeah, so I am generating the tuple of order date, and the second element is nothing but the revenue. Okay, now you can see average revenue per day dot collect for each println and hit enter, and you can see the details here. Means you can see the average revenue for each date. So earlier Gopi was asking that there were some references to underscore. Okay, so I will explain that. So the same thing which we are seeing here, this is already copied. I think you are clear till the average revenue. So I am going to the next topic. Means I am going to the question from Gopi where he sees underscores as part of the math function. So here we have declared a variable and then we are trying to use the variable. You can also write logic like this. Without passing the variable name, you can just say like this. Okay, so if you don't want to give the names and still want to invoke a lambda function, you can do that as part of Scala. Okay, and now this uh, missing parameter. Okay, I have to revisit. I thought this is the purpose of it, but I think it is a little bit different. Or probably, let me see. Let me just. No, no. I think. Let me see. Let me confirm. Okay. Dot collect for each println. Now there is some issue with the brackets. Okay, I got it. So here I have to use one more bracket here. I will check. I think there is some misunderstanding. I will check and I will confirm with you. No, it's not working. Anyway. Yeah, I also remember I saw that underscore elsewhere. Okay, so we may use the tuple of date and revenue. Uh, for what? I didn't get your question. We may use the tuple of date and revenue. Can you try underscore dot underscore one? Okay. Underscore dot underscore two. No, it does not work. Anyway, so we have covered how to compute average per day by using several transformations, because the concepts are already covered in while talking about Python in detail. In this case, I just took the example and I tried to differentiate the syntax and semantics and try to execute the program without getting into too many details. Yeah, this will give you fair understanding about how to implement the Spark applications using Scala. So that's it for today from my side. We will see how to develop another function to get the rank, whatever we have used whatever we have implemented to get dense rank using PySpark. We'll do the same thing with Spark Shell as part of the next class. Okay, and then we will be wrapping up the Spark portion of it, of the course. So if you guys have any questions, let me know. I will give a couple of minutes. Otherwise, we will close for the day. Yeah, you can call me, but I will not be able to talk to you for a long time. Okay. Any other questions? So the lazy evaluation we are finding in Spark shell is related to Spark. So Pramod is asking, he is still having the question about whether it is related to Spark or Scala. Spark is developed using Scala, as per my knowledge. So it's inherited from Scala, even if it is there in Spark. It is. So what the question is there any relationship between lazy evaluation in Scala and DAG execution in Spark? If you see the question, they are telling lazy evaluation in Scala and DAG execution in Spark. Okay, and if you get into the answer, in Scala, laziness is a language feature provided by the lazy keyword, or in some cases by using a def instead of a val. Okay, that's a good point. Actually, I think you are correct. The evaluation of a lazy expression is triggered implicitly by any reference to the lazy object. In Spark, laziness is achieved by a not so explicit distinction between transformation RDD methods and action RDD methods. You need to know which methods are actions and which ones are transformations. Delayed DAG execution is an implementation choice in the Spark library where evaluation is triggered explicitly by a call to an action RDD method. Okay, that's good, good Pramod. Thank you for correcting me. So I was thinking that it's completely Scala feature because I haven't explored Scala much yet. So that's where I'm not 100. As I have mentioned to you earlier, also I was not 100% sure, but I was confident because it's typically a programming language feature. Even here, it's a programming language feature, but it is hidden when we are trying to use the Spark. Okay. So the next question is the next question from Murali is how can we access HBase from Spark? I am not sure. I haven't done that, but some people have complained that they are still using Java to deal with HBase because Spark has certain limitations. I haven't gone into the details, but I'm not 100% sure on that. Okay, and then also Murali is asking, can I talk to you for 5 minutes either today or tomorrow? Yeah, you can call me tomorrow around this time. Means not this time, after 8 you can call me because tomorrow I will be in the administrator class in the morning. So after 8 you can call me tomorrow, 8 a.m. in the India time. Pramod is asking what is Apache Cassandra, how is it related to this course? So I'm not covering any NoSQL. Cassandra is another NoSQL database. Okay, and Cassandra, HBase, MongoDB, DynamoDB, all these are related, and I have some content on HBase already. I will be coming up with content related to Cassandra also very soon. So they are all NoSQL databases. To once the data is processed, let's take the example of Google again. So what Google do? It crawls all the web pages in the internet. Okay, and they provide page ranking, they provide suggestions and many other things. Okay, so to process the data and assign page ranking, it's a batch activity. They have to crawl all the web pages at frequent intervals and they have to update the ranks on regular basis. So it's a batch activity. They will do probably once in a day or few times a day, but it could be a per hour batch, or it could be 8-hour batch, or it could be a 1-day batch, or it could be a week batch also. Okay, whatever they do, we need not care much, but think that they will perform the batch processing on that and they will get the page ranking or suggestion index, etc. Once the page is ranked, they have to give the search results based on the page rank. So the information has to be accessed in real time. So to access data in real time, um, at the latency what Google, companies like Google is looking for, you cannot have the data in RDBMS. So they have built a new concept called Google Big Table, which is nothing but a indexed table, and the data will be in key value format. So the key will be a page ID, and value will be all the details related to page. They call it as big table because one record can be few gigabytes also. They can store whatever amount they want as part of the value. Okay, but for page ranking they might have some fields related to page, and once the page ID is passed, it should give the rank, or once the rank is passed, it should give the page IDs that are under that rank. So wherever the key can be built and get the information for that key, there these big table based technologies or NoSQL technologies will come into picture, such as Cassandra, HBase, MongoDB, etc. Another classic example is Amazon's recommendation engine. When you try to search for when you try to buy a product, Amazon recommends many products with you. When you try to buy a let's say 55-inch LED TV, you have to get recommendation with different affinities. One could be price affinity, one could be category affinity, one could be demographic affinity, etc. So all this information has to be stored somewhere, and the results should be fetched as quickly as possible. If they store in the database like Oracle, where they have millions of users and millions of products in their catalog, it will not, you will not be able to get the recommendation data that is related to the recommendation engine that fast. That's where they use the technology called DynamoDB, where the key will be the product ID. Once you give the product ID, using different affinities, it will get the data in quicker fashion, and it will start displaying as part of your buying process. So that's where these NoSQL databases come into picture. HBase, Cassandra, MongoDB, and Amazon's DynamoDB are the most popular NoSQL databases. Okay. So the next question from Mohan is, can we connect to cloud databases using Python packages in Spark? Yeah, you can connect as long as you are able to access the cloud database in the cloud, such as Oracle, MySQL, whatever database you are using. You have to you have to register those jar files with Spark, and you will be able to connect through JDBC as long as the database provides JDBC connectivity. So importing using Scoop, do we import from Cassandra DB instead of Relation DB? I didn't get your question, Pramod. Scoop can be used to import data from relational DB, Cassandra DB. I'm not sure whether they have support for Cassandra DB, but I'm pretty sure that it supports some of the NoSQL databases. So you can actually use the Scoop import through JDBC to get the data from Cassandra, means some of the NoSQL database also. I'm not sure about Cassandra. Okay, cool. So Murali is asking, while accessing HBase through Java API, while accessing HBase through Java API is good idea. If my need is read or update HBase tables from a web application, what are best practices that I need to know in this use case? I'm not. So HBase provides you only 3 features. Sorry, 4 features. One is put. Put is used for both insert and update, and then delete, and then you can get the data for which you have to build the key, and then you can retrieve the value. And then there is something called partial get. There is something called scan. Scan will typically like select star from table without any where conditions. If you want to do, if you design your key properly, you can do something called partial scans. So first thing you need to keep in mind is how to model your tables in HBase. What should be the key, and what should be the column family, and how many column families you have. For that you need to get into the HBase details. This is not HBase course. I will not be able to get into all those details. So the way I will start developing the application is, first I will understand the H-based data model, okay, and what are the how are the CRUD operations can be implemented in H-base for real-time activity, and then I will include those things as part of my DAO layer to interact with the database. If you have to do some batch processing, most likely we have to use MapReduce. MapReduce is well integrated with HBase. You can directly read data using MapReduce by just specifying the class name and then registering the table from which you need to read the data. And then as the data will be in HDFS itself, when you store data in HBase, you will be able to execute it without any issues. So the question from Murali is, I have complex front-end query while reading HBase. Can I do this with HBase Java API? So yeah, you can do that. So there are two things. One is get and one is scan. Okay. So scan is typically either to get all the records in a collection or in a table, or if you have defined your key properly, where you can perform the partial scans. You should try to use that one partial scan concept, and HBase Java APIs provide that, and you can get the data. If it is getting a value, then you have to build the key completely, and then you can use a Java-based class called get, and you can get the object or get the record, and you can create the object out of it, and you can process whatever you want to do. You can do that. But the thing is, if you are trying to implement a traditional RDBMS in HBase, and if you are trying to do joins and all those things as part of the query, HBase is not meant for those kind of activities, and you will have challenges. It's not that you cannot implement, you can implement, but for that first you need to design your HBase tables applying NoSQL concepts, not RDBMS concepts, because you should not have primary keys, foreign keys, etc. And first you have to start from there, how to define your table with key and column families, what all columns should be there in those column families, how much denormalization has to be done. You have to discard all the RDBMS concepts from the tradition if the tables are from RDBMS, and understand NoSQL concepts and design your table as per the NoSQL. You cannot replace traditional RDBMSs with NoSQL databases. You can go through any documentation. So the other question is, any resource to read about NoSQL data modeling. You can go through any Cassandra or HBase or MongoDB. You have to go through the relevant technologies documentation. In this case, you have to go to the HBase documentation, and they give details about how to design your key and how to design your column families, etc. So there is no and it's relatively simple. Unlike RDBMS, you have 1NF, 2NF, 3NF, BCNF, and there are other types of normalization forms also. Okay, but for HBase there are very few types. One final question: can I insert null value into a cell in HBase? Sorry, working on a project, so got all these questions. So there is typically we don't need to insert anything. If you understand the NoSQL data model, the NoSQL the major difference between traditional RDBMS and HBase is that traditional RDBMS you have to define the structure, a rigid structure. You cannot change it. Okay, whereas in HBase, one record might have 50 columns, and other record might have only 2 columns, and one record might have a few let's say there are 2 records, one with 5 columns and another with 2 columns, and it can be the case that the record with all 5 columns is all string, and the record with 2 columns is of type integer, and also the names can be completely different. Okay, so there is no rigid schema that will be defined on HBase. It's flexible schema. Okay, so if you want to insert null, you don't have to even insert that cell. So they call it a cell, as you mentioned. You don't even need to insert the cell there. So that's the thing. I will not even insert that one. I just ignore. So I worked on CouchDB, but they didn't provide concepts to say we didn't knew best practice. Okay, it's called key space in NoSQL instead of schema. Yeah, that's right. Again, it depends upon the technology. In HBase, they call it as namespace. In Cassandra, they call it as something else. In MongoDB, and uh, they call it as database itself. There is no schema as such. They call it as database, and table is called as collection, and record is called as document in MongoDB. So for each technology, it's a open source. Everyone have their own terms to push their tools. Whereas RDBMS means everyone follow the similar principles, like between SQL Server, Oracle, Informix, all these databases. Querying is same. Most of the things are same because most of the NoSQL databases are open source and they don't talk to each other, and there is no standards defined by by organizations like IEEE. They follow their own terminology. Okay, I will take one more question and then we will drop. Thank you for making it interactive. Thank you for asking all these questions. And also, just in case if anyone want to explore administration course after this one, I will be conducting a self-paced administration course. Even in your friend network, please share the information with them. The cost for the administration course will be only $150. So there will be 1 or 2 sessions every week. It will be 1 hour to 1.5 hour session. So they have to do hands-on. So they have to spend money either on their laptop or on AWS on top of my fee, and they have to follow the videos in YouTube. And if there are questions, they can join the class. And I will not be covering any concepts or anything as part of the class. I will be only handling the issues of the students who paid money and following my videos to learn Hadoop administration. So if any of you are interested in as part of that effort, please do join, and also please pass the word to your friends. And also I will be starting big data engineer course, as most of you guys already know, starting from September. Sir, are you planning for admin or architect course in September or October? As I need more time to practice. I want to practice and then join. So administration course will be ongoing course. It will be there as long as it works for me. It will not be, there is no start and end time for that. It will be an ongoing course as long as it works for me. Architect, there is no architect course. We have big data engineer course. It will start in September. Most of the content overlaps with this, except a few topics. For you, the content will be on YouTube and also the website. So you can go and look into those things. If you want to discuss with me, you can you let me know. We will see how you can be involved as part of the rest of the course. There won't be much charge on that if you want to be part of big data engineer, because you already paid for this course. So for other people it will be $350 for big data engineering course. If you guys want to join that, depending upon your response, I will tell you the price. It will not be more than $100 for sure. So big data engineer course is, so in this course, if you go to the agenda, so this is the last question. I have to drop off. Okay. Big data engineer course I will start in September itself. Okay. So let me, so if you see the agenda here, I am covering these things. Yeah, I will be conducting the big data engineer course at least once every quarter. So the next one will be in probably either December or January. Okay. Yeah, see, certification is different. My courses will be much beyond the certification. Okay, certification, there are dedicated playlists for the certification. I'm answering Gopi. Will I cover each and every objective as in Cloudera certification? So as part of the big data engineer course, I might not cover each and every objective of the certification course, but it will lay strong foundation where people will be able to follow my other certification curriculums through my channel and website, and they will be able to start giving the certifications. That is different. Certifications are different. If you try to club the certification with the other topics, then I will be able to teach only one thing in 30 hours or 40 hours. Okay, so certification is different, and working on projects is different. Okay, so as part of the current course, these are what we are covering: Flume and Woozy, just introduction, and then Spark using Scala, Spark using Python, etc. As part of the big data engineer course, uh, yeah, let me go to my website. And so I will be covering pig. Okay, I'll be covering Flume little bit in detail than this course. In this course, I will be only covering introduction, but I will be covering Flume in detail. Woozy also I will be covering in detail. Here I will only give one or two examples. I will not get into too many details here. But as part of this one, I will be covering Woozy in detail. For HDFS and MapReduce, we spent 3-4 classes earlier, or even more actually. But in this course, I will reduce quite a bit. And then this is the major difference: overview of Hadoop cluster setup. Okay, so as part of this one, while explaining Hive, I didn't get into the actually I got the details into Hive architecture, Scoop architecture, etc. So everyone will have idea about Scoop architecture, Hive architecture, Spark architecture, Pig architecture, Woozy architecture, etc. by the time they complete these 7 weeks. So in the 8th week, what I will do is I will demonstrate how to set up the cluster by using AWS the way we typically do in production. So I will start with cluster capacity planning, and in one shot we will try to add all the components, unlike in my typical administration course where I will cover each and every topic one at a time, and I add that topic into the cluster, and I show the life cycle of the implementation of it, like installing it, validating it, reviewing it, troubleshooting by going to logs, etc. Here I will consolidate all the information, and I am trying to provide within a week. So it will be around within 6 hours or 5 hours. I will try to show how to set up cluster setup completely. So in this course, I will, as part of this, I will not be covering the prerequisites of Linux and all those things. Okay, but you will understand how to set up the cluster. So people who are experienced will get a lot of benefit going through this course. Okay, so the cost is $350 per person. If any of your friends are interested, let me know. For you, it will be definitely less than $100, but depending upon the response I get, I will give you the final price. And also I will provide you lab access, whether you join the course or not. For all of you, I will provide the lab access at least for 2-3 months for free, so that you guys can start using my lab and provide me the feedback, so that I can actually make it better before announcing it to the public. And also people who ever join this course will also get lab access. Okay, then I have to drop. Thank you very much, and see you as part of the next class. And I will take some time to upload today's video also. I will do it over the weekend.